Come back. Today's goal of this lecture. In my previous video, I had seen what is the Cauchy's integral formula and extension of Cauchy's integral formula. Today, at first, I will see one interesting example of Cauchy's integral formula. In my previous video, I had seen many examples about Cauchy's integral formula and extensions of Cauchy's integral formula. Actually, by this formula, you can evaluate any path integral directly by this formula. As for example, e to the power z over z square over gamma, where gamma is the circle of radius 2, then this value would be 2 pi I f dash 0, and here fz equal to e to the power z, that means this value would be 2 pi I e to the power 0, and this value would be 2 pi I. That means by this, we all of us know, by these two formula we can evaluate any path integral easily. And in my previous video I had seen this. I had discussed many examples in this theorem, Cauchy's integral formula and extension of Cauchy's integral formula. Today's goal of this lecture, today at first I will see one example about this theorem, and this example is few different which I had discussed in my earlier video and few knowledgeable. This example is few knowledgeable than other example. At first I will see this example, then I will see what is the Cauchy's estimate theorem and Liouvillie's theorem. This is actually today's goal of this. This is the more extension of Cauchy's integral formula. Cauchy's estimate and Liouvillie's theorem is the more extension of Cauchy's integral formula. Okay? Well, this is actually, these two theorems actually the further consequences of Cauchy's integral formula. I will see actually today Cauchy's estimate and Liouvillie's theorem and some exercise about Liouvillie's theorem. This is the today's goal of this lecture. But at first I will see one example which depends on extensions of Cauchy's integral formula. Now evaluate the integration e to the power z minus e to the power minus z dz over z to the power n, where n is any positive integer and gamma t is the unit circle e to the power it, where t lies between close interval 0 to 2 pi. At first, evaluate this integral. Here obviously fz equal to e to the power z minus e to the power minus z. At first recalls the Cauchy's integral formula, Cauchy's extension of integral formula. F to the power n minus 1 0 equal to n minus 1 factorial over 2 pi I. Here the integration along the closed contour gamma fz over z to the power n dz. That means that imply fz over z to the power n dz equal to 2 pi I f to the power n minus 1 0 over n minus 1 factorial. This is the Cauchy's integral formula. Here fz equal to e to the power z minus e to the power minus z. Then f prime z would be e to the power z plus e to the power minus z. And we have to find f to the power n minus 1. That means here notice f prime z equal to e to the power z plus e to the power minus z, but f double prime z would be e to the power z minus e to the power minus z. That means f to the power kz would be e to the power z minus e to the power minus z when k is even, and when k is odd then the value would be e to the power z minus e to the power minus z. That means evaluation of f to the power n minus 1 at the point 0, this value would be, when k is even then this value would be 0, and when k is odd then this value would be 2. So integration e to the power z minus e to the power minus z over z to the power n dz, this value would be 2 pi I f to the power n minus 1 0 over n minus 1 factorial, and this value would be 4 pi I over n minus 1 factorial when n is even and 0 when n is odd. I hope my all viewers have understood this integration. Okay. Well, now I will say the higher order Cauchy's integral formula. What is the higher order Cauchy's integral formula? The statement is, let the function which is defined from domain to complex number which is analytic on an open set gamma in the complex number, and z0 be the arbitrary point in complex number with the condition ball around z0 with radius r contain this gamma, then estimate of the function fn z0 always less than equal to n factorial over r to the power n, where r is the radius of this disc times supremum of z belongs to del b z0 absolute value of fz. That means f to the power n z0 always less than equal to supremum of this function on this boundary times n factorial to the power over r to the power n. This is the higher order Cauchy's integral formula, and this formula is known as actually the Cauchy's estimate formula. Why this is Cauchy's estimate? Because here the derivative of this function estimate to supremum value of this function. So this theorem known as Cauchy's estimate formula. The proof is such type. We all of us know the extension of Cauchy's integral formula means fn z0 equal to n factorial over 2 pi r integration fz over the boundary del b z0 z minus z0 to the power n plus 1 dz. This is the Cauchy's integral formula we all of us know. Now if we parameterize the curve r e to the power it plus z0, then this integration would be reduces in n factorial over 2 pi I integration 0 to 2 pi f of r e to the power it plus z0. Here z0 would be vanish after putting, this would be r e to the power it to the power n plus 1, and dz means I r e to the power it, and this value would be here r to the power n plus 1, then this value would be r to the power n, and here f of r e to the power it z0, and here e to the power it, here e to the power it n plus 1, and here e to the power it. So this value would be e to the power it times minus n dt. So here this is the absolute value n factorial over 2 pi, just pull out from absolute value, and here 1 by r to the power n, then use the absolute value absolute integration 0 to 2 pi f of r e to the power it plus z naught, and we all of us know absolute value of e to the power minus it times minus n, this value would be 1, so here dt, and this value always less than equal to supremum of fz. So this is less than equal to supremum of fz. So this value would be less than equal to n factorial over 2 pi I 1 over r to the power n. Since this is less than equal to supremum of fz, and integration dt over 0 to 2 pi, this value would be 2 pi, and here z belongs to del vz0, and that means 2 pi and 2 pi, this would be cancelled, so this value would be less than equal to n factorial, sorry, here I also would be cancelled, n factorial over r to the power n supremum of z belongs to del vz0 absolute value of fz. I hope my all viewers have understood this is. Notice the estimate. Derivative fn z0, absolute value of fn z0, here less than equal to n factorial over r to the power n, supremum z belongs to del vz0 fz. This is the Cauchy's estimate formula. Here the higher order derivative estimate to a function. Okay, I hope my all viewers have understood. Next I will see what is the Liouvillie theorem. Now I will see what is the statement of Liouvillie theorem. At first I will say the statement of Liouvillie theorem is if fz is analytic and bounded in absolute value, and this is true for all z in a finite complex plane, then we can tell fz is constant. That means bounded analytic function in a absolute value always be constant, and this is true for all z. Consider this is the open ball z naught. Around this point z naught, consider the open ball. That means bounded analytic function in a absolute value always be constant, and this is true for all z. I will see the proof. At first, consider one arbitrary point z naught in the complex plane, and consider one arbitrary ball around this point z naught. Since the function is bounded, that means there exists capital M greater than 0 such that absolute value of f of z less than equal to m, and this is true for all z belongs to in the domain D. Since function fz is analytic, that means we can apply Cauchy's estimate formula. Okay? Therefore, by Cauchy's estimate formula, absolute value of f prime z naught, this value would be less than equal to, notice the Cauchy's estimate formula, f prime z naught less than equal to n factorial over r to the power n, supremum of z belongs to del vz in z belongs to in the boundary around the z naught, supremum in this boundary, absolute supremum of the function capital Fz. Since here f prime z naught, therefore n factorial would be 1 and this would be r. So f prime z naught would be, and since all value of, since f is bounded, that means this is less than equal to m, that means this value would be m over r. Okay, by Cauchy's estimate formula we can tell this is, and here I have applied the Cauchy's estimate formula because the function is analytic. Have you understood why Cauchy's estimate formula is very important? Okay, and since here this r is arbitrary, so we can take it as large as we please. So take r goes to infinity, then absolute value of a prime z naught, this value would be equal to 0. And this is true for all z belongs to D. That means that implies a prime z equal to 0. Absolute value of a prime z equal to 0, and this is true for all z belongs to D. Since absolute value of a prime z equal to 0 for all z in the domain, so that implies the function f is constant in the domain D. I hope my all viewers have understood what is the Liouvillie theorem. When fz is analytic, since analytic, so I have used this Cauchy's estimate, and for boundedness we can tell this. So the function is constant in the domain, and this theorem is very important for higher study. Also, use of this theorem is very important for higher study, also for all competitive exam. Use of this theorem. Here one thing very noticeable. Here notice I have taken r tends to infinity, but I have told fz is analytic and bounded in absolute value for all z. That means I have start from this radius, and we can increase this radius at infinity. So actually Liouvillie's theorem is applicable for entire function. So actual statement of Liouvillie theorem is, if fz is entire and bounded in complex plane, then that implies obviously the function fz must be constant. I hope my all viewers have understood why in every book the statement of Liouvillie's theorem means has indicate if fz is entire and bounded in the complex plane, that imply fz is constant. Because this, I have started from radius r, but we can increase this radius infinitely. So actually Liouvillie's theorem is applicable for entire function. Okay? Well, now I will see one theorem based on Liouvillie's theorem. Let fz be an entire function, and if uxy equal to real fz, which is bounded for all xy in the complex plane, then that implies the function f is a constant function. Why? Given fz, that implies this is entire function. Here uxy equal to real fz is bounded, and fz equal to obviously uxy plus ivxy, and given real fz is bounded, that means ux comma y, modulus of x comma y less than equal to m for all xy belongs to complex plane. Here given real fz equal to bounded for all xy in the complex plane. This is our given part. And we have to prove f is a constant function. For this, consider new function e to the power fz, where since fz is entire, So obviously e to the power fz, this is entire function. I hope my all viewers have understood this clearly. Okay, e to the power fz means e to the power u xy plus I v xy. If we apply mod, then this imply modulus of e to the power xy times modulus of e to the power I v xy, and we all of us know e to the power I v xy is 1. So this is e to the power u xy. And since given u xy less than equal to m, that means this would be e to the power less than equal to e to the power capital M. Apply the Liouvillie theorem. Since e to the power fz is entire, and here I have got this is less than equal to e to the power m, which is bounded. So since entire plus bounded, that means that implied by Liouvillie theorem this is constant function. So I have got this implied this is equal to constant function. Okay, that implies e to the power fz is constant function, and if e to the power fz is constant, that imply always fz is a constant. I hope my all viewers have understood this theorem elaborately. Similarly, if given vxy is bounded in the complex plane, then similarly f is also constant function. Okay, similar function if fz is entire function, and if vxy equal to imaginary of fz is bounded for all xy in the complex plane, then uxy and vxy are constant function. Why? Because here fxy equal to fz equal to uxy plus ivxy, which is entire function, and here given vxy, which is imaginary fz, here given this is be bounded function for all xy in the complex plane. Since given vxy, which is imaginary fz, is bounded, that means similar to before, absolute value of vxy is less than equal to m, and this is true for all xy belongs to complex plane. But here consideration is in different way, since vxy, which is imaginary fz, is bounded given. So consider gz equal to e to the power I fz. But here I will consider not only e to the power I fz, I will consider e to the power minus I fz. Why I will consider e to the power minus I fz? Because if we consider e to the power I fz, then obviously gz is entire function, and gz means just put the value of fz, this value would be e to the power I uxy minus vxy. That means e to the power I uxy times e to the power minus vxy. If we apply mod, then this would be modulus of gz equal to e to the power I uxy times e to the power minus vxy. But here the difficulties. For these difficulties, if you consider e to the power minus I fz, then for short calculation this would be e to the power minus uxy plus vxy minus uxy plus vxy, here would be plus vxy. And this value is equal to 1 times e to the power vxy. So, since this function gz is entire plus bounded. So by Liouvilie's theorem we can tell e to the power minus I fz, this function is constant. And since e to the power minus I fz is constant, that imply obviously fz is constant. I hope my all viewers have understood why Liouvilie's theorem is very important. This is actually exercise of Liouvilie's theorem. Okay? Well, I will stop here. In my next video, I will discuss some more exercise about Liouvilie's theorem and extension of Liouvilie's theorem. But at first, I will highly recommend you please see today's video with pay attention. If you don't see my previous video with pay attention, then today's topic and the future topics cannot be understood well properly. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.